Welcome to Big Kaiser, Craig.
Show me around.
Well, we have our showroom, which is a permanent on display of everything that we offer here in the United States, as well as all other parts of the United States, in also Germany, Switzerland, Europe, Japan, everywhere that we sell our products. But what's unique about this showroom is it is all the products that we offer always on display. So you can come tomorrow, next week, it's all here anytime you want to see it. It's not like we set it up special occasion. So it's a permanent situated showroom that we are very proud of. It's also got some equipment here that we can do some demonstrations on our products and also do some test parts. So we've made this showroom in a way that it's based on the types of products that we offer. So we've got our boring systems on one side, we've got our tool holders in another area, we've got explanations on how they all work, little interactive displays. So some people might want to see how those would work in their situation. So we've made these little mock-ups of what that would look like.
Well, we're going to get into all of it, but I associate very first Big Kaiser with boring. So let's start there.
Yeah. So the boring systems, anywhere from 16 thousandths to 80, 100 inches, whatever you want to try to do.
16 thousandths?
Yes, sir.
That's unbelievable.
16 thousandths is a very small hole, but it's still some critical parts. When you're trying to circle mill or ream something that small is really difficult. And still you have to bore them.
Right.
And yeah, we can bore down to 16 thousandths. I don't know if I have one of those on display because you can't really see it.
So you're right, you need a magnifying.
But the funny part about this display, this is the boring systems, twin cutters and fine boring tools and whatnot. People will look at this and they you know the saying, you can't see the trees through the forest.
Sure.
They don't see that big black thing right there. They look through it and they're like,
unbelievable. Yeah,
that's actually
unbelievable.
That's actually a boring tool. So you're looking at a 100+ diameter boring tool that would have or could be used on different types of things. Windmills were a big popular item for this type of product, and still is, because those types of components, these transmissions, required to be bored on a horizontal boring mill.
Sure.
You can't do them on a turning center, so you need very large diameter boring tools to do that. And we typically stock those. So again, you know, people don't see, they're looking at this and then they look behind and they're like, oh, wait a minute, let me get back there. That's actually a boring tool back there. Wow.
That's incredible. Well, and the future of boring seems to be digital and automated control.
Correct. So we've been investing for the last 10 years on new technologies. You know, we're a mechanical company from Switzerland. For more than 70 years, that's what we based our reputation on, was precision of mechanically applied product, which means high precision scales inside there with, I shouldn't say scales, but micrometer spindles and things that we produce mechanically, and that's how it all reads. Now, in the last 10 years with digitalization, we've been able to put the digital into the tool on the display. And that was our first generation, was just a digital readout. We called it our digital boring head. But the next generation, we're calling it as a EWE, it's electronic. And why we call it EWE electronic is because it's got some capability with Bluetooth connectivity. We can actually put in through our app the different parameters that we want to run this tool at, and we can put the tolerance fields in there. We can also look at the history of how the tool was used.
That's incredible. And something you talked to us about was the idea of a boring head that can be altered in the machine from the control. So if you're finding something in QC that is a small amount oversized or undersized, that's not something where the machine stops and the tool comes out and you fix it. Rather, it's something that can be programmed and altered on tool.
That is a newer product we're starting to develop. That's called our EWA. That's an automatic adjusting tool. So currently, most boring tools, they do require that manual intervention. The machine does have to stop. It does require somebody to go in there, make the adjustment, and then continue on. With the automatic adjustment, we're actually putting little servo motors inside the tool, which reacts to the command from the machine, which is based off of the probe, which told it you're a little undersized or you're a little oversized. Or, you know, what we're trying to really set up is a tool which has the functionality like you would see on a lathe. It has a wide work range. So instead of, let's say you got a work piece or work pieces, you know, if you're in the different work pieces and they all have bores in them, but they're all in a certain range that this tool can do, it'll automatically adjust from bore to bore to bore, whatever size it commands. So instead of just a particular size, which is typically what boring tools do. They work on a specific size, and you only adjust for tool wear. These heads can actually be moved from, say, 68 millimeters to 75 millimeters and then back. And it's a huge range, yeah. Obviously, smaller tools, not so much.
Sure.
But,
we work very hard to hit very exacting numbers when we're making parts, and that's a great challenge. But we're also very concerned with high uptime. We want our machines to be running as much as I can, because if a machine's not making any parts, the machine's not making any money.
Yep.
So the idea of the investments we're making in probing, being able to work with investments that we're making in tools, is you're living in the future, Jack. It's
well,
really
ideally, the best boring tool is the one you never have to adjust.
Right.
And that's what we've always had as the back side of what we do well. You know, it's the repeatability. You get it set and it stays there consistently. You know, if we've got customers that'll be making large plates with 100 holes on it. Each hole's 50 millimeters or 2 inches in diameter from start to finish, and they're just hitting all these holes going all the way down. And when you can see that the first hole to the 100th hole has not changed more than a tenth or two, that's what people really like, that they didn't have to make those adjustments. And
a video that we did at a time, we were making our zero reloading press, and John had a handful of them that had come off of their early ones. They were done on our UMC, but they were done with a Big Kaiser boring head. And he's got them lined up upside down, and in a key bore, he has a quantum mic, and he's dropping in, and they're all within a few millionths of one another. It was a really unbelievable display of, you can do this. You couldn't possibly do that interpolating. You couldn't possibly do that in many other ways.
Yeah.
But with a boring head that's bang on every time,
yeah,
it's crazy what can be done.
Yeah, and like I said, it's got to go through tool changers, which are fast, and it's trying to push those tool carriers out of its position. The repeatability of a tool change, is really important, that when you're setting up and the tool does its job and it goes back in the magazine, well, you want to recall this, it better be in the same spot.
And to that end, your tool holding is the other, the big plus tool holding, the big capto. That's the other huge portion of the business that we see laying around our shop all the time.
Yeah, and we started, the name Big Kaiser comes from two companies come together.
Kaiser,
Right, Big Daishowa of Japan with Kaiser Boring out of Switzerland. We're Big Kaiser, and they're known very well for the tool holders that they produce, and they've always made them to a standard which is well beyond what most people expect. And they always say, why are your tools so expensive? And we don't need that kind of precision. Why don't you make a tool which is not so precise? Well, that's like telling Porsche, don't make a car that's so good.
Right.
You just can't tell people.
Why would you intentionally make something
you
less
don't,
nice? Right.
So you choose your markets. And what we do is we know that we're not going to be everything to everyone. There are certain customers that appreciate it and will rely on it, and there's some that just don't see the value or need in it. But the tool holders are certainly something we take a lot of pride in. And I go back to the taper finishes.
Right.
When you look at the tapers on every tool holder we produce, whether it's just a basic arbor or a high precision hydraulic chuck or whatever it is, they always make them to the same precision. And that finish is really what you can see is a starting point, because that's got to go into the spindle extremely accurately.
Right.
That's where the repeatability of every system starts, is how those tapers match up, whether it's an HSK, a Capto, or a steep taper.
Right. And we've made personally, our company's made enormous investments in DMG Mori is right next door. We've got a whole fleet of machines, but if the tool doesn't sit right in the spindle, who cares? You lose before you start. I also heard an interview, I think it might have been with Chris, about the idea that in tool wear, and you'll correct me because I'll be wrong, every 10,000th of run out creates a 10% reduction in tool life over time.
That's a pretty good way of saying it. What we say is a tenth equals 10.
Okay.
As in a tenth of run out adds or subtracts 10% tool life.
Perfect.
So if you've got half a thousandths of run out as a baseline, let's call that 100, and you add a tenth of run out, let's go to 6/10, you theoretically lose 10% tool life. And if you go the other direction, if I subtract 2/10 off that 5, I would gain 20 to 30% tool life to it.
Well, and as we do more and more steel and titanium and harder things to cut than 60-61 and 70-75, it's made a big difference for us in having the right tool holding so that certain end mills, that let's say we blow through making brakes, if we can get 20 parts versus 10, or even 12 versus 10, that's uptime on the machine, that's tool costs that we're managing. Everything's, the idea of paying a little bit more for a tool holder to make that machine run more consistently, to save tools, to us it's a no-brainer. We're obviously doing it. We're big Kaiser customers.
I like to look at it from the point of view of the tool life, of course, is a big impact on your cost total. But I like to look also on the setup. That you can put a tool together, and let's say you're putting a 1/2 end mill into a tool holder. Do you know that it's going to cut a 1/2 inch? Right? So what is it actually going to cut? And that's where like a tool presetter will give you a more definitive number what that will look like based on runout. And when you know that a 1/2 inch tool is going to cut pretty close to a 1/2 inch, you don't have to make these offset changes.
Of course. Now you talked about setup. Let's talk work holding.
So our work holding systems are not to actually hold work pieces, but it's actually a quick change system for the fixtures themselves.
Sure.
All right, it's a way to decrease the setup times from one job to the next, and that's a big difference maker. You know, if you can just look at the simple things like taking a vise off the machine, and you got to replace it with something else, maybe it's a dedicated fixture or a rotary or whatever, you're usually working off T-slots. T-slots aren't very accurate. You got to swipe them in, you got to find out where that thing goes, and if you take it off, put it back on, it's not like it just sits in it. It's a time. Some people will say I can do it in 5 minutes, some people will say, oh, it takes at least an hour, but it's there. With the purpose of 0 point or 0 point system clamping is that I can establish my datums on the machine table. All right, they're permanently fixed, I know where they are, so if I take the part off and I put it back on, I know exactly where it is. If I take the fixture off, put another one on, which has got its own 0 offsets, I pick up exactly where I left off before. And because of the way it works, it's all air actuated with mechanical clamping.
That's really nice.
It's very fast. It doesn't require hydraulic lines to keep it charged, so you can just put it in the machine. The air is what helps it to release, and once you take the air away is what locks it. So it's a permanent lock-in without the air.
Lock by default is nice as well.
Pretty much, yeah. Once you remove the air, it's locked, and you only need the air to unlock it.
Sure.
Yeah.
We've got boring heads, we've got tool holding, we've got work holding. Then there's the entire other half of the showroom here, and we're going to come back and we're going to talk about some presetter type things. But let's talk about how you fulfill and how you repair.
Okay.
So what are we looking at, Jack?
So this is our repair room, and in this room I have a great qualified staff of repair techs. They are capable of fixing everything we sell.
That's amazing.
Right, so the advantage there is pretty much things come over from Japan or from Switzerland and they don't go back for repair. They stay here. So if a customer has a problem and they need tool fixed, it's going to happen eventually, that something just breaks or gets damaged, whatever. It comes into this room and our repair techs can make on-the-spot analysis. Is it repairable? How much is it if we want to repair it? And then we got a huge amount of inventory of spare parts to fix just about everything from angle heads, digital boring heads, any work holding system, whatever the customer would like.
Something that struck me here, a lot of companies have repair for their analog or their mechanical parts in the US, but you guys also, all of your electronic parts can also be maintenance here.
Yeah, we just brought that in last year. It's the new electronic components that we use on our digital heads are a little bit more plug and play than they used to be. The original ones, we were learning, we were running wires through the tool and all that, and it was kind of complicated, so kind of left that in Switzerland, but now it's a plug-in module. So we have the calibration equipment, we have the electronic components that we can actually replace them ourselves here and get the customer back on their way pretty quick.
Walk me through.
Well, careful. So these are the staging areas, just like parts come in and the customers get in the queue, so to speak, and we take them all apart and we find out what's wrong with them. And that's a big part of it. Sometimes customers, drop off the car and they don't tell you what's wrong with it. It's
right,
like, okay.
We get that. Nobody in any industry likes maintenance and returns. I mean, there's always an element of dependence on minimal amounts of information or some fickleness that can come from a customer. So
But we adapt. You know, we always tear them all apart anyway.
Sure.
We're going to clean them all up, and then we're going to find out, you know, when we put it back together, if there's bad bearings or if it's got a broken screws that are key. Obviously, we'll fix those. But
Sure.
it can be, you know, anywhere from $100 to a few $1,000s, depending on what the tool is.
Of course.
But we got that, and we got different pieces of equipment. We have balancing machine and test stand for spindles. We can run in any of the tools that need to be running. We check temperature, we check noise, believe it or not. Yeah, because we want them to go out pretty much in the same condition as a brand new tool.
Sure.
It's not going to look brand new, but it's going to have the same performance and it's going to have the same value as a brand new tool.
Inside a work envelope are not, they're not conducive to looking like new, but as long as they perform, that's what really matters.
Very much so. So we don't have a lot of, you know, there's no production going on in this shop, so it's a lot of manual equipment for making jigs and fixtures and alterations. It's mostly hands-on, taking tools apart and replacing all the parts that need to be, and making sure that at the end of the day, when it goes back out, it's as good as brand new.
Because you don't want to see it back.
You know, we get customers once in a while say, hey, I can really, it's a lot of money to repair that. Can't you just use some of the parts that were still in it? And we can say, well, we'll do that. You know, if you want us to put those old gears back in, but you got to know that it might not be as good as what it should be, and it might not last as long. So just weigh that in mind. And we usually talk them out of that, you know, because you got it here. Just spend a little bit more, get those things.
It's a premium brand. You're not selling a budget tool. You're selling what I think is a value tool, and that you spend the money to have the right part.
Yeah.
And you don't want it to come back in and then send something out that is less than what the big Kaiser name is.
And we've got competition. There are companies out there that will offer to fix our products.
Sure.
They don't have, of course, the original parts and things like that. They don't even buy them from us. We don't sell them. Customers aren't even allowed to buy the parts for the most part. And some of these tools are kind of locked out.
Sure.
You know, if you don't have the fixtures, the special tools to get them apart, you can't do it.
Well, there's a massive amount of knowledge of the tools here that can't possibly exist anywhere else.
No. And we'll fix tools as old as 20 years, unless it's really just, it's time to say it needs to go to the graveyard.
Yeah, you gotta have that hard conversation.
You know, obsolete tools and new tools. That's a big question, right? People like to use everything as long as they can, and I get it. You know, you want to keep using what you have is still functional. We've got tools out in the field that have been there for 40 years.
Sure.
People have taken good care of them. They still work. There's nothing wrong with them, until the point that they're looking for a repair on it. At which point, we'll sell you every small spare part that was a catalog item to keep that tool running, as long as you want it. But when it comes to a repair, then we start putting a timeline on there of about 20 years.
I understand.
Tools made 20 years ago, we're probably not gonna.
And you've got 22,000 part numbers, I think is the number I was given?
Yeah, I think it's about, if we take all the different parts, it's over certainly 20,000. I know for sure.
Let's go see them.
Yeah. So in our warehouse, it's obviously space is always key to making sure that we
feel that.
Try to utilize it as well as we can. So vertically is obviously going to take less space than horizontally. And this Rimstar unit here is where we house all the boring systems, because they're smaller and they are easier to manage in a very easy way.
And I've got to imagine this holds multiple thousands of part numbers.
Literally, I'll say it this way, millions of dollars.
Sure.
Literally sitting in here. So it does have hundreds of part numbers, and they can command up whatever part number they want that they need to ship. It'll bring it in, tell them exactly where it is, point to it, and say this is the one.
And this is the epitome of accurate, secure inventory.
Yes, and that's great and it's bad. So if the power goes out, we can't get into it. That doesn't happen very often.
Right.
But yeah, that would be the only
nice
part of
battery
that.
Backup for this guy.
Yeah. We're shipping out anywhere from 100 to 200 packages a day. Could be large orders, could be small, like somebody just needs a few screws, a couple inserts, and the little box, to a huge pallet full.
Sure, and we actually live in a very similar outbound package number daily. So we get the challenge that comes with, once you get past 20, 30, 40 orders in a day, everything starts to happen a little different.
Yeah.
What you're managing and your resource allocation, your personnel allocation, the technology required in making that really work all the way down to just dealing with your UPS rep. It all changes.
So we're also receiving goods from Japan and Switzerland, and our manufacturing down in Tennessee weekly, all the time. So that's got to be brought in. It's got to be inventoried. It's got to be put on a shelf. Back orders got to be run. So it's a lot going on here sometimes.
Sure.
Yeah, and the other storage is the bigger items, I call them, the V-flange shanks and the capto and the milling chucks and all the larger
items. As Rousseau
items.
junkies ourselves, by the way, this is amazing.
Yeah.
We love a good Rousseau cabinet, and you're there in spades. It's beautiful.
Yeah. So, it would be ideal if we could find a way that we can start automating this, like
Sure.
get the Amazon ways of doing things. But inventory like this is very flux. We can see, 1 year to the next, a very popular item becomes less popular, a very unpopular item becomes popular.
Right.
And if you allocate specific shelving space for
Manufacturing
something,
requires volume
all of a sudden it's like,
requirements.
oh, now we got to add this because now the volume's gone up. We got all this extra inventory. How do we manage it? It's always a shifting target in here.
Well, and it creates categorically waste to be able to manage that over time, because your bays need to be the same size. You
Yeah.
need to have reach in all of them, and then have unused for that growth. So
Yeah.
automation's cool, but there's very real difficulty in it.
Yeah.
And automation doesn't like stuff like this. As you've got small parts in these bins.
Well, we've got a product in the tool presetters. We call it the IntelliGo system, and we're actually considering to bring it in here. It will provide more intelligence to where the stock is located. It will actually automate that. A drawer will be opened for you to tell you where it is, and just like we did over there, we can start to bring a little of that into here.
That's really cool.
So I don't know what Chris told you, but yeah, the inventory is on the tool holders much higher than the boring. It's almost double because there's so many varieties of different parts compared to boring's got a lot, but the tool holders, if you can imagine all the permutations of just a simple collet chuck.
Right.
You got the different sizes collet chucks, you got the different links, you got the different interfaces, you've got to manage all those with volume.
And every variable grows exponentially. When you multiply combinations.
Yeah, and
just adding one more thing gets.
And if somebody says, I like to buy it without this little piece on it, all of a sudden now you got to stock it that way, or with the piece on it. It's all kinds of.
How do you manage that? Because every industry fights with that the customer wants something different or custom.
What
becomes SKUs,
I think you still,
custom,
you just try to be flexible when you
Sure.
know it's necessary. And we get a lot of special requests. Can you do this? Can you do that? And obviously it requires us to take the workpiece or the tool out of the package and modify it or add something to it or whatnot. And it is obviously a wrench in the gear, but we manage through it.
All right, so we're going to talk about presetters, but before we do, Sphinx cutting tools.
Swiss product that we've represented for over 20 years. They're made in the French side of Switzerland. So if you know Switzerland at all, that's where they make a lot of watches. And they get into a lot of micro tools, and they get into a lot of high precision tools.
Some of these tools are terrifying, Jack. And I'm talking about, first of all, I don't know where that one ends and the air begins. And then we've got tools here with a reach multiple that is
very
daunting.
Long. Yes, up to 80 times D for micro tools. But their specialty isn't so much on just the standard, but also on the specials.
Sure.
They like to take a process. They want to say, what does that shape of hole look like that you want to produce? They'll take that and they will define the process of tools with specials, with steps, and all the things that it needs to have to do that as efficiently as you possibly can.
Well, one of the reasons a presetter and capto makes so much sense to us from a production standpoint is reloading dies. Now, this is a forming die that brings brass down to a very specific size after firing in a rifle. And the tolerance available inside that die to do it really well is very small. So tool life on that finish reamer, on that final reamer, it's hugely important.
Yeah.
And making sure that it's accurate is a reason for a presetter, but tool process and making sure that tool, that final tool, is doing the amount of work that will allow it to live the longest is also it's a big deal. We'll spend a ton of time on that.
So Craig, I can't emphasize enough, what you're talking about is something that it's a process. You got to put all the parts together, and that's where the tool holders with the cutting tool, we can guarantee a little bit more than maybe the X factors out there. So there's a lot of companies that make cutting tools, and they make them very well, but there's not a lot of them that make cutting tools and the high precision tool holders to go with it and say, we've got the process for you. If you use this tool holder with this special cutting tool, we can guarantee the whole result.
It's something we see all the time in the machining world, in the firearm world, is people will try to cut a corner somewhere, and what they're really doing is compromising their entire system.
Absolutely, every time. So you can spend tons of money on the cutting tools and carbide, and if you try to save a little bit of money on the tool holders,
if they're not running true, you're wasting them.
Exactly. Or it's not cutting to the right tolerance, or it's not giving you the finish that you were looking for. It's oversizing, it's bell mouthing, it's all kinds of things that can happen. So that's what I like to say. We can, if you want a Capto tool holder, we can give it the highest precision available on the market. Whether it's Capto or Big Plus, we've got it. And we can give you the cutting tool with the highest possible concentricity.
But how do we know they're perfect? Let's talk presetters. So the reason presetters are so intriguing to us now, like I said, there are two parts that make a lot of sense in Area 419. One, that is, as we make reloading dies, making sure that that final finish reamer, that form tool, is exactly right. Because in any cutting tool, you're going to see wear, especially cutting into a steel. And we can maintain a certain amount of wear, but a very small amount of wear. And a form tool is difficult to measure manually. The other tool that makes a lot of difference for us is one of the end mills that cuts the ports in our Hellfire match. They're fairly long, they're fairly thin, and they are doing roughing work inside a pre-hardened 17.4. Mm-hmm. So that 1/4-inch end mill, Marcus pops those fairly regular.
Right,
and inside the mill turn, we've got a bank in the magazine that's a handful of these tools. But when it's time to daily go in and reset all them, we don't want the mill turn, which is a terribly expensive machine. It doesn't need to be down for an hour while he works. So we can fix that.
I like to first say, people call them presetters, and that's exactly what they do. But in the real world, they're actually a tool measuring system.
Sure.
That's why we call this product line our TMS, as in tool measuring system. It's not tool measuring software, it's systems. And what it can do is not only preset for it to go on the machine, but it can do that inspection.
What's Patrick got set up here?
All right, so this is a porting tool, and this is inside our Speroni Futura Presetter model. So it's kind of our heavy hitter. It's going to be our largest and most accurate and precise Speroni model that we have. So I've got the porting tool chucked up in the spindle, and right now the software is designed to measure the whole tool stack, holder and all, and it's actually scanning the tool about 4 millimeters at a time. And then at the end, it's going to give us not only a DXF, but a 3D model. So we can use this for anti-crash simulations or looking for any kind of wear based off of the tool manufacturer's DXF model. So you can see it's just following that profile all the way up. And we'll get towards the top of the cutter here. So it'll stop, and then it's going to generate a 3D model for us.
And in this tool, can you build plus-minus windows? Can you build tolerance windows on certain edges, certain shapes, certain sizes to tell me yes or no, is that tool ready to go back in the machine and continue to be used, or is it time for retirement?
Yeah, absolutely we can. So what I'm doing here, this is primarily for running simulations and primarily for, anti-crash, if you're using Vericut, for example. This is exactly how you do that. If I wanted to measure this to see if this is worn down, we have a different measurement cycle that we can do. So I can switch gears here. So I'll be in my preset screen, and then I can just simply search for this tool in my search bar, pull it up, and then I have a bunch of predefined measuring steps over here on the top right.
Sure.
So this has all been pre-programmed. So all I need to do is tell this to run. So it's going to auto find the top of the top of the cutter. This way, since it's in a colleted tool holder, if the stick out's varying, the presetter is going to automatically find wherever that tool is with varying stick out. And then I also, and it might be hard to see, but I do have plus or minus tolerances built into the nominal X and Z dimensions for each step. So once it goes through and measures all 4 cutters at the top portion, it's going to measure max height, max diameter, and the runout. And then it'll come down and it'll measure each step all the way down. And so now it's doing what's called a max profile. So since we've already verified that my runout's okay in the first step, it's just going to spin 360 degrees. It's going to capture the maximum profile at that step. And then it'll apply what we call a macro. So in this case, I'm getting an angular intersect point. And it verifies it, and it'll move down.
All right, so we're going to capture a huge amount of data on this tool. What do we do with it?
So once this is run, the next thing we're going to do is, assuming everything's in the green and nothing failed, we'll print a label, and on that label will be a QR code. So I've done us a favor and already pre-printed that out, and so this is exactly what that looks like. So once this is finished, I can just peel this label back, and I can stick that right on the tool holder. So this is automatically being converted into metric since our Okuma is running in metric. So here's a perfect example of when something is out of tolerance, it goes red and it stopped and said, hey, you're out of tolerance by quite a bit here. Something's wrong. Something's either worn or you've grabbed the wrong cutter. It'll give you that nice visualization. Like I said, this was pre-measured. So I can slap this right on the tool holder, eject the tool, and then we have a wireless QR code scanner. So this just goes right on the shop's Wi-Fi, and this can float around the shop, so it'll integrate to any machine that's on the network and going to be used with this, and we can take this over to the machine center and shoot our offsets right in. So the way this system works, I already mentioned, it's running off Wi-Fi. I've got my tool with the QR code right on the tag, and wherever you're going to be loading the tool in, so if the tool changer is on the side or if it's on the front where we load in the front of the machine, we actually have a barcode. So the idea here is that to reduce fat finger errors, we scan the tool first, so it's prompting me to scan the tool, so it beeps. Now it says scan the machine, and that's what this barcode is. And you'll see tool 305 instantaneously pops in, and my offsets
They're in. We're done.
Within about half a second, it'll show up. So it's a pure safety feature. We can do this direct from the presetter. So if, let's say, you only had one machine, it'd be pretty safe to just send it on out. But hey, if you got a dozen machines, it only takes an operator to accidentally click the wrong thing, and you're going to have a bad day.
Right.
That's why QR code, extra safety.
It's very cool.
Yeah, it's really slick.
All right, well, guys, we appreciate it. And this is what's being done here and what it means to shops from a quality standpoint to a future-facing standpoint it's really cool. So thanks for having me.
Oh, thanks for coming by, Craig.